I would suggest you unmute, it would be much better. Good morning.
Yes, let's make this an interactive session, right? Um, like I said, we will be not deep diving into the concept, but when Ankit is taking the session, if you have any queries while understanding this, you can just unmute yourself, or you have a raise hand button. Just raise your hand. We can see you, and Ankit can ask you to put up the questions. So let's make this interactive. Thank you. Okay.
Thank you, guys. So today's agenda, we will like to cover what is the traditional network. We will understand the limitation of the traditional network that we are using from almost 10 to 15 years. Then we will understand what is SDN. We would understand the architecture, basic principle of SDN. We would also undergo the how the SDN can help the limitations imposed by the traditional network. And at the last, we will also take a glimpse at the SD-WAN technology. Okay, so let us go through one by one. First, we like to understand what is a traditional network, what we are using, and what are its limitations. So, guys, as you can see on your screen, this is a normal traditional network where you have multiple devices. Let's say router A, router B, router C. You may have switch, you may have any kind of devices. We have taken a generalized approach here. It could be from any vendor. Okay, it's a normal architecture where each device in the network is connected physically with each other, and they are running some routing protocols. Okay, so routing protocols, if you take an example for OSPF, BGP, ISIS, LDP, RSVP. So there are so many legacy protocols which we need to run once we use this architecture. Okay, so what happens in the normal architecture is, normal architecture means your normal router, traditional router, have three planes to manage the network. First one is your control plane, management plane, and data plane. So control plane, when we talk about, control plane is one which is responsible for doing the routing. If any one of you has gone through the HCIA datacom previously or have gone through any CCNA, so you must be aware that control plane is responsible for routing. Okay, let's say you enable OSPF on router A and OSPF on router B. So OSPF do exchange some messages between each other, between the routers. Okay, OSPF between three routers means OSPF will use its messages to exchange the route with each other. For example, router A knows something, it will tell to router B. Router B knows something, it will tell to router C, and they will exchange with each other, and finally they will come up with a convergence, and they will build their routing table. Okay, so at the last, router A will build a routing table saying, okay, these are the total routes in my network. Okay, so every protocol that we run is counted as a control protocol, or you can say control plane. Messages of these protocols are under control plane, means routing decisions are being taken on the control plane. Management plane is one which is responsible for managing these devices. Managing these devices means, let's say uh, you wanted to take some fault reports. Okay, you come in the morning into the office, and let's say you wanted to fetch, okay, give me the fault or any alarms in my network during the past 24 hours. So management plane is one which gives you the fault, the any event, any failure, any SNMP traps, or you want to push some configuration also. Management can also help you to push some of the configuration. But usually management is for the performance management or fault management. And data plane is the final one where you are taking your packets and they are using the routing tables and gets routed from one place to another place. For example, any packet comes to router A, it will check its routing table, gets routed and reaches here. So means overall network is being divided into three planes: data plane, control plane and management plane. So this model is called distributed networking, where each device in the network has its own brain to calculate the routing protocols, to calculate the routes. Okay, control plane, data plane, management plane, everything is there with the device. Okay, so every device contains its own control plane and its own forwarding plane. Management plane has been unified for the ease of management, which you call NMS. For so many years we are using NMS, so where we have used SNMP protocol to centrally manage the device. Okay, but control plane being remained as it is. Control plane remains as it is with the device. You cannot ask a device that you don't take your decisions. Okay, so brain remains with the device. Now in this architecture, what are the challenges? Let's discuss this. So number one challenge that we face is inflexibility. Inflexibility means the configuration part means you have to configure each and every device individually. Okay, even after NMS is there, but you can say the network does not offers you any feature where you can configure multiple devices at once. You have to configure each and every device one by one. Let's say in case of expansion also, so every device has to be integrated one by one into the network. Complete testing is required end to end, and then only that device is accepted. Complexity of the network. Okay, complexity means when you have a increasing network requirement, so you cannot plan the network in advance. You cannot plan the network in advance. Let us suppose today you have planned a network for a small area. Tomorrow you want to expand. Okay, tomorrow you want to expand to some another area or some another applications. So today you are using OSPF, tomorrow you say like you want to use ISIS, because that OSPF is not scalable now. After ISIS you says okay, no, I want to use BGP because I cannot control the routes. After BGP you started to use, okay, let's say I have to use LDP now because I have so much of latency in my network. So you cannot plan the network from day one. As the network expand, the complexity increases in the network. Okay, so this is what we face with the traditional network. When the complexity increases, obviously the operation and maintenance also increases. Okay, network provisioning also becomes slow. Network provisioning slow means there are multiple reasons. One is your again we have to configure each device individually. We have a complex network which has so many protocols, okay, which are somehow working. Third is multi-vendor. Most of the network are not built on single vendor. Okay, people use multiple vendors to make their architecture robust, and when you use multiple vendors, obviously the provisioning becomes slower. You cannot make a template and copy paste on another device. Every device has its own CLI. So these are some of the limitations. We will discuss more. Inflexibility can be explained in other terms. For example, you have a network like this. These are your 5 locations, 5 cities, I would say. Okay, these are 5 cities of your network: city 1, city 2, city 3, city 4, and city 5. You have 5 PEs in your network, and you have deployed, let's say, 10G connection between each of your cities, assuming that this should be enough for intercity communication. Okay, now there's something called traffic engineering. Traffic engineering is done to ensure that you have a reserved bandwidth for a particular application. Okay, you don't feel congestion, you reserved bandwidth. Okay, link between router A and B is the shortest path and will face congestion soon. The other link are idle. Let's say you have to go between router A to B. Okay, you have to go from router A to B. So traditional network traditional network convergence will happen based on the shortest path first. Okay, whether you use BGP or whether you use OSPF, or because every protocol converts based upon IGP, and IGP uses shortest path. So traditionally it will take shortest path, means from A to B you will use this link. You have 10G capacity here and you have 10G capacity here also. So you will use, let's say you have consumed 6G out of your 10G. 4GB is left. You have another application which demands another 6G. Okay, so you have now total requirement between A to B is 12G. Earlier it was 6G. Now it has increased to 12G, and you have dimensioned it only 10G link. So you will say, okay, I cannot use this link for my 12G requirement. Why cannot use this path? Why I cannot use this path for my another 6G requirement? So in order to achieve this path, we have to use traffic engineering. Now traffic engineering also has its own disadvantages. Traffic engineering also has its own disadvantage. For example, we will go with this service requirement, where first requirement is A to E 6G, second is C to G 4G, and third is C to D 8G. Okay, A to E 6G means we will provision, let's say, A to E based upon sequence. First requirement, first one, like A, and here is your E. If we take this path A to E, first one, this one, you can see in the gray, A to E. If we reserve 6G on this, what would happen? Second requirement is C to G 4G. C means this device and G means this device. So let's say you take C to G 4G link, and you take this path C to G for 4G. Okay, that's fine. Third requirement comes C to D 8G. C to D means you can take this path, but guys, can please tell me, can we take this path C to D for 8G. Our total capacity for the link is only 10G. We have used path 1 6G, path 2 4G. Now third requirement is 8G. Can we take this path C2D? Guys, please uh, respond if you understand this. We have C2D, total link 10G, only 10G. Out of 10G, I have on for this path 1, I have already consumed 6G bandwidth. Only 4G is left on this path. And my requirement is now 8G, 8GB. Can I take this part C2D? No, right? So if I cannot take this path, I will choose this path, let's say. This path also I cannot take, because here to here it is okay. Up to C to E we have a bandwidth, but between E to D again we have a bottleneck. E to D again we have a bottleneck. So the entire issue is, initially we have taken this A to E. When we were choosing path between A to E, we had two options. Either we take A, B, C, D, E, or we take A, F, G, H, E. We have two options. But we didn't know that what would be the future requirement, and we have taken A to E upper path. Second path we have provisioned like this. Third path we have provisioned, and we are unable to fulfill the requirement. So that means traditional network is inflexible. If you want to shift this link from upper one to below one, below path, there would be lot of service disturbance. There would be lot of service disturbance. Whatever services are running from A to E will get disturbed. Now we take another approach. In this approach, same requirement. Okay, same requirement. How we are fulfilling? Global view means here you do not manually provision those paths. Traditional network, when we use traffic engineering, we provision paths based upon the requirement, based upon sequence. And here we put it onto the SDN. We put all the requirements to the SDN in irrespective of their sequence. Let's say today requirement 1 came, you put it. Day after tomorrow another requirement, you put it. Day after tomorrow third requirement, you put it. So SDN will do the global calculations, and it will adjust all the paths as necessary. It will cater first, second, third, all paths, all requirement equally. All requirements equally. So this is the advantage, means your network is flexible now. Your network is flexible. Traditional network, whatever you have used, you cannot alter. You need a lot of migrations to do this path change. Lot of service interruptions is there. I hope it's understood. Any doubts here, guys? Please speak up. Complexity we have discussed, that if you want to become an IP expert, you might need to read 2500 RFC documents. 2500. You may not only need 6 years, I think you may need 60 years to understood these 2500 RFC. Any one of you have gone through RFC, guys? Any one of you has ever before it any RFC? RFC is actually stands for request for comment. Whenever any new technology comes in, so whether this technology comes in by any vendor, any OEM, or 3GPP releases, so they put RFC on the web so that people can comment for that technology. It is a, you can say, first public document for any upcoming technology. Okay, so these are the documents based upon which actual technology is used or implemented. So if you want to become a network expert, you need to read all those RFCs, which is not possible. Another challenge is lot of protocols. You have to understood lot of protocols while using the traditional networking. You first need to configure IGP, then you might need to configure BGP, then you need to configure MPLS, then you will create VPN instances, you will configure MPBGP. So there is a lot of CLIs that you need to push in, and that will vary vendor wise. That will vary vendor wise. Okay, it will not be same. And this is the very good limitation, I would say. Slow network provisioning, or I would say standardization. Let us say, you have a requirement that you want to build a application. You want to build an application, a web page. On the web page, you wanted to say, let's say, I would take an example. Let's say you guys are from army, I believe, from defense. Is tomorrow somebody, some new person joins the defense, and you have to give him the access to the network. Okay, so maybe what you do nowadays, you create a user and you just uh, add one more user for him and give him the access. Similarly, let's say this task is easy. Okay, you just add one more user and it's okay. Let us say you have to change, you have to integrate one more device in your network, one more application, one more server, I would say. Okay, one more server into your network. So uh, how you will integrate that server? How you will integrate that server? You will integrate that server means you will physically take any of the router or switch, plug in the cables, do the IP routing, and make it up. Okay, so that is traditional one. So you are just making IP reachability. But can you give him a some kind of user interface? Can you build some kind of user interface, some kind of web page where you just fill up a form, click submit, and all your routing is done? This kind of feature is not available in traditional network. In traditional network, whenever some application comes, some server comes, some new extension comes, everything has to be done manually. You have to plan, you have to first do the planning. Okay, what are the VLAN requirement, what is the port requirement, what is the IP requirement, what is the connectivity, what is the communication matrix, this everything, all data, what is the physical architecture, everything you need. Then only you can integrate any server into any network. But you cannot do it on a single click. So standardization, when we say standardization, means any miscellaneous requirement, let's say industry specific requirement, company specific requirement, company specific portal, that kind of requirements cannot be fulfilled by the traditional network. And if somebody even wishes to do this, it would take years to standardize, because multiple vendors need to support it. You have to build a protocol, and then only it would become a large scale deployment. So I will give you more example on this. So let us see now what is SDN. Let us now see what is an SDN. Guys, any doubt so far? Till now I am speaking only, nobody is responding. Any doubt so far in the traditional network? Shall I repeat any part of it? Okay, I assume no doubts here. So let us see what is SDN. So till now we have discussed that SDN means control plane and data plane remains with the device. Okay, control plane and data plane remains with the devices, and the devices will take its decisions, or in simple words you can say brains. Currently brain is there with the device itself. Every device has its own brain. SDN will use a centralized brain. SDN will use a centralized brain. These devices will just keep data plane with itself, and control plane will move to SDN box, a SDN controller, I would say. So none of these devices would have any brains left. They are just having data plane. This device will do all the routing. It will take all the calculations. It will generate the routing table, and it will give that routing table to this routing device. Okay, so whatever calculations, whatever decisions has to be taken, whatever policies has to be implemented, that could be done by SDN. The end result, the end routing table, okay, or the MAC table would be pushed to the data, the forwarding device, and this forwarding device will forward data based upon the same. It cannot take any decision by its own, now. Decisions will be taken by the SDN. This is what we call SDN, software defined networking. Now, software defined networking is introduced by clean slate project. Clean slate project. Okay. It was started by clean slate project during the some of the research work, where physical separation of network control plane from forwarding plane, and where control plane controls all the devices. So currently in traditional network, what we have to do, we have to go to each device, we have to configure protocols, everything. Now when we use this architecture, there would be a controller sitting in. So all this protocol stuff will be done by controller, which can be controlled using a software, because this controller can further be controlled by another application. This controller can be further controlled by an application. Now when we use this architecture, we use some protocols. We use some new protocols in order to connect these devices with a controller, and again with controller to the application. So we use this architecture where all these devices will connect on one protocol with controller and maybe another protocol with application. So let us see those in details. So in order to manage networking devices in a centralized manner, we put control plane into a new component called controller, or you can say SDN controller. SDN controller. So earlier we used to had these protocols IGP, MPLS, LDP, BGP, which is now not necessary. These protocols were used for a distributed architecture. Now they has become unnecessary. No use. Controller manages the control networking devices in a centralized manner. So all these routes calculations, IGP, MPLS label, everything is done by controller, and the result is deployed onto the forwarding device. Prime advantage is the view of the network. View of the network. View of the network, when I say, means currently, let's say if you have a large network, very large network, okay, so you have to keep your topology. How do you maintain your topology nowadays? If anyone can answer me, anyone has uh, the architecture of their topology? Guys, any one of you do maintain the architecture of your topology? I would say network diagram of your topology. Am I audible, guys? Am I audible? Okay. So I am asking, any one of you is responsible to manage the network? Is this controller is within the router? No, no, no. Controller is not within the router. Now it is a separate device. Controller is a separate device, okay, which is purely called a controller. You can call it a server also, and just the routers have now to support the SDN technology, and they talk with SDN controller. So I'm asking, any one of you has uh, if responsible for networking in your networks, how do you manage your current network? If I ask you, do you have the network diagram of your current network? Or if have, like, how do you manage it? Entire diagram, every device connected. You have a network. So you have a network diagram, you have made it manually on Excel's PPT, Word, or the Visio, or yes, you have made it manually, or you are using some protocol, some software, some application to have a dynamic update on the same manually, right? Let us say tomorrow you add two more devices to your network, okay, or you reduce, you take out the two devices from your network. So would you enjoy the some dynamic updates in your topology? Do you manually manage each and every device addition, and let's say some operational challenge happen, you have changed some ports, so do you manage those devices, those ports details, those VLAN details, those IP details? That much details are covered in your network? I hope not. You cannot cover that many details in a network diagram made out manually using Visio or some of the Office application. And you cannot scale for a bigger network. Smaller network of, let's say, a building, maybe you can manage, but a bigger network spread across a country or spread across a city, yes, it would indicate. I don't have an SDN controller access at this time. I can show you all the faults will be, see, failures, if I say failures was a feature which was indicated in the traditional network also, because that's a part of management plane. Management plane. If some link fault occurs, so that was indicated using SNMP also in the real time, in the traditional network also. Over the time we have managed this much. But if some topology change happens, some new network addition happens, some port change, let's say your port 1 has become faulty, you have shifted the cable to port number 2, but you are using same VLAN, same IP, everything is same. I'm not sure you could manage that in your network. No, no, it is difficult to manage. I understood, but over the years, the different vendors has offered many applications. We call it NMS, which gives you this flexibility. However, not you can say when you buy an Android phone. When you buy an Android phone, some of the applications come inbuilt, okay, and some of the applications you need to buy externally. You have to download it from the Play Store. So the one which comes inbuilt is purely tested. That's why Apple or Samsung is giving you within the phone. But some of the applications you need to pay extra, or you have to take it from Play Store. So similarly, when we talk about operation and maintenance, the NMS, that part you have to take separately. You have to pay separately. That does not come in a bundle. Okay, and you have to develop that application to the point where you can see real-time faults. Okay, so that is one thing. Management is one thing. The view of topology, we are talking about view of your topology, real time view of your topology, which is very hard to see. View of the topology, which is not viable in a traditional network. With help of SDN controller, with the help of SDN controller, we can have a real time view of our network. Can have a real time view of our network. In a very large scale network also. So this is the one of the very good advantage. If you ever try to log into any of the SDN controller, there's a option to go to check topology, and topology will show each and every connectivity, your complete network diagram, connectivity, port details, everything you can see. Next is open interface. Open interface. Centralized programming is simpler than distributed programming. Some of the people use programming, okay, to you can say automate their task of configuration. Automate their task of configuration. But it is not possible. It is not possible to do the distributed programming. It is not scalable. Okay, it is not scalable. Scalable in the sense you have 10 different vendors in your network. You cannot make a program for 10 different vendors. And even 10 different vendors, one vendor may have 2 or 4 type of devices. So every device has its own CLI, For every CLI, you will make different programs to automate. With the help of open interfaces, there would be one single interface which will connect with the devices, and the application layer, there would be no change. After forwarding device are centralized, managed by the controller, controller provides an open interface to upper layer application. And if any new service requirement means, let's say you try to say, I need to build an web interface where user itself can create any network change. User itself can create a network change within the few clicks. He don't have to submit the requirement on email. You don't have to take any approvals or anything. Everything is automated, just few clicks. Okay, let's say you want to, I'll give an example. You want to shift this link, from port A to port B, and this link from port A to port B. You want to change the IP of these two interfaces. You want to change the VLAN for this interface. These kind of changes. Okay, so I'm just taking a smaller example, a bigger one also. Any network change, traditional network, how you will do? You will prepare a config, you will log into the box, do the config changes, and then this would be done. So this cannot be done instantly. Today, you can write an application here. You can make a program here where you will just open up some web application, put up some form, give some inputs, and click submit. The application would submit the requirement to the controller. Controller will push the config in real time to the devices, and your changes will be done. Okay, so this interface, between the controller and the application, is open interface. There are lot of open interface, such as RESTful. RESTful is one of the application based upon Yang model, which can be used to communicate with the controller. RESTful is one of the protocol, you can say. It's an open interface. Similarly, here you can use netconf, BGP, SNMP between SDN controller and your networking device. Okay, so this is the architecture. Networking device means, which is called infrastructure. Controller is your control layer, and application. So tomorrow you will change something in your networking device. Let's say you change some of the networking device, you want to make some changes, physical connectivity, VLAN change, IP change, architecture change, application change, anything. Okay, so the user sitting at the application open up a web page, do some changes, give some input, click submit. This will pass this information using an open interface to SDN controller. SDN controller will build the config, okay, do the required routing, do the required changes, and share the updated results with the networking device. So this is centralized. Infrastructure layer. Infrastructure layer mainly consists of forwarding device, responsible for forwarding traffic. So infrastructure layer is nothing but just doing the forwarding of your packet. Whatever end user devices you connect here, whatever end user devices you connect here, so it will take the packet from end user devices and it will forward from one device to another based upon the output, based upon the uh, you can say the forwarding table given by the control layer. Forwarding table can be a layer 2 forwarding table or a layer 3 forwarding table. Layer 2 forwarding table or a layer 3 forwarding table. So layer 2 forwarding table means your MAC table. Okay, MAC table, ARP table, FDB table. Okay, VXLAN when you start to use. Layer 3 forwarding table. Layer 3 forwarding table can be your IP table, VPN v4 table. Okay, so this is your layer 3 table. Infrastructure layer and control layer are communicate using southbound interface. So this interface is your southbound interface. Okay, and this interface is now called northbound interface. Southbound, northbound, southbound and northbound. Okay, southbound interface which is based upon open flow. Okay, and northbound interface based upon restful netconf. These are the new protocols which you need to understand in order to use those applications or in order to build the applications which can communicate with an SDN controller. Any doubts here? So any doubts here, guys? Any so far?
Hi.
Yeah. Hi.
Hello.
Yeah. Tell me.
The netconf, is it using southbound or northbound?
Netconf is used in southbound, but netconf is also there's a one flavor which is used along with restful. So in northbound also it can be used over restful.
Okay.
Proprietary it is primarily it is used in southbound. Netconf, OpenFlow, BGP, all these SNMP protocol, all these are used in southbound.
Okay. Thank you.
Does SDN controller has a proprietary restriction according to vendor? See, traditionally yes. Usually nowadays what we see, every vendor, if you buy a set of devices from there, they will give your their SDN controller which can control their devices. They are using some proprietary methods, but there is some open SDN controller also, okay, based on open standard, which is like open daylight you can say, ODL, open daylight. Okay, open daylight has a limited support, but it is an open means it would be it can be used with any vendor whomsoever is following the open flow protocol or netconf, so it can be used. Next question is there any specific hardware device available for SDN? Yes, there is a special hardware. Special hardware means nothing, it's like a software is proprietary. Software is proprietary and the hardware can be see again, uh, you can use nowadays what we use VNF means you take an hardware from anyone. It's nothing but a server. Okay, you take an hardware from anyone, you virtualize it, put an hypervisor on it, and on the top of the hypervisor you install a VNF. VNF comes from the vendor. If you are installing for Cisco will give you, Huawei will give you, or any other vendor. So now concept of cloud is running. So hardware is anyone, but yes, VNF means the software you have to buy from the specific vendor. SDN controller can be used for existing traditional network. Uh, I would say no. Traditional network does not support SDN controller because they need to support that API. Okay, there is a different API which is being supported by forwarding class. In traditional network, that support for SDN controller is not there. You have to take up a new forwarding devices which supports that. And mostly what is supported by traditional devices, SNMP. If you use SNMP to control, means I think there would be not much advantage that you will get until unless it start to support OpenFlow or netconf. So for netconf, there is a different model of objects within the forwarding device. So that model has to be supported, and that is not supported in the traditional. Cisco offers, for example, Nexus. There's a box. Nexus is there. Okay, Nexus can work in ACI mode as well as in traditional mode. It has two software to boot. If you boot in Nexus OS, it will work as a traditional. If you boot in ACI, it will work as an SDN. Okay, so I would not say it is a traditional box. Nexus is an old device, but when they started it, they has a vision of putting compatibility with the upcoming technology. Can SDR controller can be used for existing traditional network? Okay, next question. Why people does not use OpenFlow based controller if it can manage any device? Yes, that's very good question. OpenFlow actually is a protocol, but the controller is called Open Daylight. Open Daylight, or I would say Open Daylight is an VNF or a software. Okay. First of all, this is open, so means there is no support. There is no support. Okay. Let us suppose you run into a problem. You run into a problem with your forwarding device. You buy a forwarding device from Nokia, and you run an ODL onto it, and let's say some of the features are not working as intended. So who will you will reach? That boss, this feature is not working, this is not working. There's no support for that. OpenFlow community, the Open Daylight community can support, but the support will be slower because that's free. You cannot go to them and say, boss, I need a solution by tomorrow. No. So every vendor, every network owner who deploys, although there is a lot of deployment based upon ODL, it's not like it's not deployed. People, it's popular ODL because it was the first controller. It is popular. So many deployment has already happened based upon ODL, but due to limited support, people don't use it. See, ideally, the concept to develop the SDN controller was for the same thing, that so that a single SDN controller can support multiple vendors. Today, complexity of the network is you have one device of Cisco, let's say Cisco Nexus you have, another device Cisco ACI you have, next device you have, let's say ASR 9K you have 3700 you have, okay, next you have Huawei NE40, next you have Huawei S5700, you have CE device. So there are so many product families, each product family have its own CLI. Okay, you want to configure BGP in each family, so the CLI for configuring BGP in Nexus would be different. Okay, ASR would be different, normal switch would be different, 3700 would be different, NE40 would be different. Okay, CE 6800 would be different. Okay, So every vendor has its own CLI. For a network engineer, it is very difficult and very confusing to understand all the CLI. So that is why this clean slate protocol which has been started, the vision was, because there was a lot of discussion happened on this when this thing came into the picture between the so many communities worldwide, OEMs, that why don't build an application which can support which can connect with multiple vendors, which can support multiple vendor CLI, and we don't have to learn multiple vendor CLI, and the SDN controller will take care of it. Okay, but there's a limited support. OEMs, especially OEMs, manufacturers, shown very less interest on it, very less interest. And you know the reason, you know the reason. Nobody wants to close its shops, right? They cannot close its shop. If this thing comes, means there's no proprietary thing, there's no USP for the vendors left, right? There is no USP. So people, the OEM has a very less interest on going to that part. According to the three layers of SDN, such as app, control, and forwarding device, interfaces are standardized or differ with service provider. I didn't understood this question, Major. Interfaces are standardized or differ with service provider. Can you please repeat this? Interfaces means? See, Huawei supports all protocols: OpenFlow, NetConf, BGP, PCAP, SNMP, all protocols supported. Support means you can use any of them. Major, can you repeat your question? Standardize or differ with service provider?
Actually southbound and northbound
Mm-hmm.
interface. That protocol, that interface protocol का standardized हो इसे differ with the service provider. Differ with the UI.
No, 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 it is standardized. It is already standardized. The interface is already standardized. Means interface has to support OpenFlow. Interface has to support NetConf. Okay, so interface is standardized. Only thing is, interface means when you use this protocol, it uses usually what you say HTTP based or web based, XML based instructions are passed. But XML, interface is standard, but the object model SDN controller is accessing some objects inside the forwarding device. For example, it has to change IP address. So IP address, for changing IP address, it would have an object into the forwarding device called IP address. So that model may vary with vendor to vendor. Model may vary. That is why not every SDN controller can connect with every other vendor. Okay, for transferring they will use the same standard, same interface, but for accessing the AND object can vary. Understood? Means what is happening is the OEM has been forced to standardize this. Okay, but they are not showing much interest. They are not showing much interest, so they have standardized some part of it. Let's say interfaces they have standardized, but the objects they have not standardized. This object tree, if they standardize this object tree also, okay, then the actual thing will come. Then the actual thing will come. And that is also over the years every vendor has developed its own every device they have their own you can say the objects, the way of configuration, the CLI. So they cannot change it so easily. Okay, so that agreement between the vendor has to come. If that has come, that means any SDN controller would be able to control. Okay, so as of now it's a limited. You can type it on Google, just find RFC for SDN, you will find a lot of RFCs. It's public. IETF is the organization which manages, so you just type it and you will find it. But I must tell you, these SDNs, RFCs are very difficult to read and they are interrelated. It's not a complete document, they have so much of references, and the language is not so easy. You can try reading it. Any more doubts, guys? Okay. So when we talk about application layers can be used based upon any of the protocols such as OpenStack, OSS. Okay, mainly nowadays SDN being used in data centers. Okay, now SDN is used in data centers. So in data centers you deploy the SDN, you have so much of spine and leaf architecture, okay, where you use the SDN to control all this. Okay, enterprise also started using it, okay, where the internal network of that is being used. So many applications people started to build, such as security applications, service provisioning app means you want to provision a service to a customer, so that can be done in few seconds. Infosys has done some of the applications, okay, which has been given access to the end user. So now end user does not, earlier people has to send an email to the company boss, I need this service, I need this data, let's say. So now they have given the access to the end user, that you go onto this portal, click this and you will get this data. Let us go for the advantages, although we have discussed. Rapid network innovation, network simplification, moving from COTS hardware trend, automatic service provisioning, and real-time network traffic path optimization. SDN controller is able to obtain real-time network status, as I have already told you. Real-time network status, okay, information such as bandwidth utilization, service traffic rate, traffic optimization. Until now, you had management plane. Okay, management plane means you have a read access. You have a read access to the network, that what is happening, what faults are occurring. So you get reports. But in order to rectify those faults, you have to send the teams. You have to align different teams that will configure, that will plan, and then the any fault will be restored. Now real-time traffic optimization means as soon as the fault occur, the SDN controller will alter the path. It will change the path, optimize the path automatically. So this was not possible earlier. SDN open programmability. Open programmability means I'm not talking about an application. Let's say you build an app in your mobile phone. You give it to some third party company, and you will say some IT company and say, okay, boss, you build me an application with name uh, ABC, whatever you name. Let's say you want to give it. You open up your phone, open up that app, and you will see real time picture of your network. You will want to do some configuration changes, you have an access. You want to fetch out some reports, you can have. So any customized application, I'm saying, whatever is your requirement, whatever your day-to-day challenge is, based upon same, that IT company will give you an application. That application will be installed on the application layer, and that application will use the RESTful API to access the SDN controller, and then SDN controller will give you the report. This is the biggest advantage. Sorry, I would not be able to show you these things because since it isn't just an introduction session, this requires lab access to the devices, and that I don't have at this moment. So any further training, if you take there, we can arrange a lab session where we can do a lab on the SDN controller, where we can show how the SDN controller works, how it interact with the forwarding device, how do you configure all the protocols, how these protocols working all together. So that is a lab session. So, and at much time I don't have an access. ENSP, no. ENSP does not support SDN at this moment. Yes. When we discuss these in the lab part, EVPN and VXLAN would be obviously a part of the configuration. ENSP does not support, so you need an access to real devices. Real lab is required. VXLAN is very complex, and that is why SDN controller makes it easy. Some of the SDN controller offers to provision it automatically by using the link layer discovery protocol. Okay, initially when you switch it on, you give the IP range, VLAN range. Okay, and you just connect the physical cables. So LLDP does explore the fabric. It assigns the loopback IP, and it just make the VNIs from end to end, and VXLAN setup is ready. So this is a part of your SDN controller, which we cannot demonstrate in this session. I can only say role of EVPN and VXLAN is manually you have to configure a lot of things when you want to build EVPN tunnel or VXLAN tunnel. But SDN does it automatically. SDN will ask you inputs only. Okay, SDN will ask you, okay, what is the IP range? Let's say in the fabric you have 2 spine and 8 leaves. Okay, so it will ask you how many leaves you want to configure, how many spines you have to configure, how many what is the IP address range. Okay, for point to point, and for loop back it will take it from you. From VLAN range it will take from you, VNI range it will take from you. So input it will take, and you will click next, and it will automatically discover the fabric and do it for you. Understood? That goes with vendor. That goes with vendor. If you buy it from Cisco, Cisco usually have a stricter license requirement for every feature. It controls by license. Huawei usually does not have so much strict requirement for the license. Whenever you buy a product, you usually get most of its features. Okay, Huawei, Nokia, but Cisco, yes, Cisco has a lot of strict requirement for the licenses. So that is based upon the vendor licensing. White papers you can Google, it would be available if given by Huawei. But material related to this HC, you have you can search HCIA SDN. HCIA SDN is the certification course of Huawei, which talks about the all the uh, connectivity, architecture, configuration, lab, everything is there. It's I think a 5-day program. There you can go into the detail part of the SDN. So let's move on. Any more doubts here, guys? Simplification, network simplifications. This is second advantage for the SDN. SDN characteristics. Now OPEX has been drastically reduced. OPEX has been drastically reduced because you are moving the control part into the controller, so the cost of this equipment also reduces. Or cost of this equipment also reduces. The control plane is centralized, so the cost is also reduced. Commercial of the self hardware, that means nowadays you don't need to stick to the vendor based. Now see, this is the advantage actually offered by SDN. But again, if you use open daylight, if you don't use open daylight, you may have to stick with the traditional hardware, means proprietary hardware. Otherwise the advantage says that traditional, see, proprietary hardware can be removed. You can use any vendor hardware and you can use SDN to control it. Automatic service provisioning. Automatic service provisioning means earlier you used to build app to control different devices one by one. In centralized approach, one single application sitting on the top of controller can provision any service, just few clicks. Any service, any kind of requirement, any custom requirement can be met. Traffic path optimization. Traffic path optimization. Nowadays, the biggest drawback of our network is, let's say you build a full mesh network. You build a full mesh network. Even after building full mesh network, your path from A to B will be based upon shortest path. Based upon the shortest path. For example, this link is 90% utilized. This link is 90% utilized. This is 92% utilized. 80% utilized. Okay. Now in order to reach from A to F, if you take the shortest path, means you will take this link, then this link. Shortest path will take you to the most congested link. Shortest path will take you to the most congested links. So for example, Google Map. If you see Google Map also shows you the shortest path, okay, and it does not vary based upon traffic. It will show you the options. Nowadays, it started showing the options to take you the alternate path which has less traffic, but still, first it would show you the shortest path. Similarly, network also shows you the path which is shortest, irrespective of the congestion. It won't take into the consideration that link is already 90% utilized. Why don't take other path? It won't take into the picture. Okay, but this thing can be optimized, or you can say it is auto optimized with SDN controller. SDN controller has a real view of the network. It knows what links are congested, what links are free, what links can be used to load balance the traffic. Earlier, there was only one way to do is traffic engineering. Manually you do the traffic engineering, that this packet will go from here, this will go from here, this will go from here, and eventually you end up mess up the entire network. You end up messing up an entire network. You take years to build the traffic engineering, and you take another year to remove the unused path, because traffic engineering will reserve the path whether that traffic requirement is today there or not. Okay, so that was very complicated technology to build to reserve the path. Real time optimization means it will have a real picture. Whatever path is free, it will take that path and it will take you to the destination. Okay, so all of your links will be equally utilized. Okay, you pay a lot of money for each link. You pay a lot of money for building each link, and if that link is not used, okay, most of the time in the network we see which link is overutilized, let's augment. But we never see which link is less utilized, let's load them, because there is no protocol to load unused traffic, unused path. So this will further reduce your cost. You think of it a way, currently your network is few links are 100% utilized, and you assume that your network is fully utilized. Actually your network is only 20% utilized, because you are calculating the utilization based upon few links, not all the links. When you start using all the links, means there would be lot of bandwidth, there would be lot of bandwidth, there would be lot of space uh, available to you before you augment and put more money. IP, outgoing IP. See, the traffic does not forward it through the controller. Afaq, I'm not sure your name is Afaq. The traffic is not forwarded by the controller. Controller is sitting at the top and giving the routing decisions. Okay, whatever your application, let's say you have an ISP network here, you have a network B here, the traffic will come from here, pass from your forwarding device, go here. The controller will not take traffic. No, you have multiple controllers in your network because of redundancy. It is always recommended that you install minimum 3 controller, because it's single point of failure. Because of single point of failure, you assume that in your network you have one brain only. If that controller goes down, becomes faulty, means your entire network is down. That is why we build 3-point redundancy, and only one controller will be active. Two of the controllers will remain standby. They will sync configuration within each of them. Once any controller becomes faulty, the other controller will take over. Okay, so these are just active standby for redundancy. Minimum 3, based upon your topology size, it can be 5, 7, 9, whatever. but traffic is not forwarded via controller. Yes, it will not allow. So that policy, see, you will make that policy onto the controller. Okay, that policy will be pushed to the forwarding device. That ACL will be pushed to the forwarding device. Forwarding device will check, okay, I am allowed to forward only this IP, this source IP. If it is not beyond this source IP, I will not allow. Decision will be taken by controller, but the hands, you can say the limbs or the action will be performed by the forwarding device. It is not the controller will filter. It will only tell, okay, boss, this IP is allowed. You can take it in another example. If you have seen a modular box, let's say any 40, in which we have multiple cards. We have MPU, we have LPU, we have SFU. LPU is responsible for forwarding plane. MPU is responsible for control plane, and SFU is responsible for switch fabric. Okay, so MPU part means control part. Control plane MPU does not forward any traffic. There would be no port on MPU. All the traffic forwarding is done by LPUs only. MPU is just sitting on the traditional box, doing routing calculation, building the fib table, and giving it to the forwarding plane. That's it. Whatever ACL, whatever user input is there, it is there. Whatever configuration is there on MPU, and it will push it to the forwarding device. So same thing here. Understood? Afaq, I think. Okay. Now at the last, we will understand the applications for SDN WAN. So guys, as of now, if you have gone through this, you must have understood SDN is a technology. SDN is a technology which gives you the leverage to control your network centrally, and which gives you an advantage to build third party applications on the top of SDN. Okay, similarly SDN came first, and then we got a requirement for SD-WAN. So see, SDN and SD-WAN ideally the same thing, basically the same thing. The difference lies in terms of its application. SDN is usually used in enterprise network. Okay, mainly it is used for access network or enterprise network. Means, let's say your college network, your company network, your building network. Okay, or data centers. You can use for data centers. Okay, data centers. Let's say you have, let's say 10 leaf. Sorry, 2 to 10 spines. On the spines you have 40 to 50 leaves. A data center is there. Okay, which is at one place. I would say physically all the devices at one particular roof. SD-WANs comes into the picture where SD-WAN comes into the picture where you have an application on the larger part of the network, means your WAN network. WAN network. For example, here you have an MPLS network, you have an ISP network, and one of the customer premises equipment is sitting in city 1, another is city 2, city 3, city 4, or maybe across the larger boundary, across the larger boundary, at the one end of the country, at the other end of the country. So, for example, I guess in Sri Lanka there is a network called what is the favorite ISP provider there? Can anyone name? Like in India, we have Airtel. So if we take an example of Airtel, network is spread across the country from one point to another point. So when we manage that network, WAN network, so that application is called SD-WAN. Structure will remain the same. Netconf, SSH, BGP, all these protocols will remain the same. Okay. Control layer would be the same. Okay, which is SDN controller. Okay. For example, Huawei has iMaster NCE is the product which offers you SDN controller features. Okay, and this third application layer is third party. Okay, you can use any IT company and build an application which will talk on RESTful. So SD-WAN provides portal pages for carrier, large enterprise, very large networks. Okay, so this is SD-WAN. Allow customers to customize portal pages through northbound application SD-WAN. Control plane means where iMaster NCE will use to connect with these devices. Okay, iMaster NCE will use to connect with these devices based upon netconf. Okay, network layer will remain the same, means where it will forward those devices. Okay, however, SD-WAN deployment is still limited. SD-WAN deployment is nowadays also still limited because changing one bigger network to total SD-WAN is a very bigger call. Okay, you can upgrade a data center, you can do expansions based upon SDN, but changing a all network is you can say it will take time. You have to replace all the devices. So you can see these are the devices, customer premises equipment, which are being controlled by an RR, or you can say an SDN controller. Okay, sorry, not RR. RR means root reflector. Root reflector. So what is the approach has been taken here is, these are the forwarding devices. These forwarding devices, instead of the SD-WAN controller connecting all devices, we make a root reflector here. Root reflector is connected with SD-WAN controller. All the calculations are done by this. Push to RR. RR will push to all the devices. This is one another approach. So we can discuss more approaches of SD-WAN and SDN in the detailed session of SDN if you guys wishing to continue that. But for now, this is it.
Ankit, I'll be taking over.
Okay. Thank you guys.
Yeah, can you help me just stop sharing so that I can share my screen?
Just 2 minutes.